Welcome back to Rubik's Structures. On these tutorials, we'll be teaching you how to model portal frame using the frame generator on Autodesk Robot Structure Analysis Professional. Okay, so you come to New, click on New. So we're going to select the project. Since it's a portal frame, we'll be using this Frame 3D design. So you click on Frame 3D design, allow your software to load. Okay, when this happens, the first thing you do is for you to come to your tools, come to your job preferences. It's very important to come to your job preferences first on robots, so you don't make a mistake with your units and dimensions. Okay, so and set them properly. So you come to unit and format. Okay, what default unit do you want to use? You want to use imperial, which has to do with foot, inches and megapascals. You want to use metric. For me, my default is metric unit. So a metric unit has to do with meters, millimeters and kilonewtons. So you come to your dimensions. See mine, my structure dimensions in meters, my section dimensions in centimeters, section properties also centimeters, my steel connections dimensions in millimeters, my diameter of reinforced concrete bars is in millimeters, my reinforcement area is in millimeters square. So my crack width is millimeters. You come to force. Okay, so my force is in kilonewtons, moment is in kilonewton meters, stress is in newtons per millimeter square. Orders, check this. My displacement is in centimeters, my angular rotation in data is in degrees, angular rotation, the result I get is also in degrees, so temperature in degrees Celsius and all of that. Check and make sure these dimensions are in conformity with what you want, unit edition. So this is it. And come to your materials. So materials I want to use based on Eurocode. Okay, so the basic set, my steel grade of steel is 275S. My concrete grade is about 20 to 25. Aluminium is aluminium design and timber is C22 24. So come to database. Is database I'm using for European section database. For my vehicle load I'm using Eurocode 1, and for my load database I'm using EC1. Weight loads according to Eurocode 1, EN 199121. Okay, so you can check all of this for design code. So we're steel and timber, I'm using European sections, my vehicle load, Euro sections and all of that. So you can come to your design codes. Design codes, make sure my load combination is this, snow and wind loads is this, and seismic load is this. Okay, for structure analysis you can check your model analysis and all of that. So coefficient of participation you check. For my structure analysis I usually leave this sub iteration, so you can check non-linear analysis and seismic analysis to be sure if you're okay with all of this. And you can save your current parameter whatever as a default. So whenever you open your Autodesk Robot, you would have this as your default preference. So you press OK and OK. So the next thing you do after setting your dimensions from your job preferences, for you to come to your add-ons and you come to frame generator. You click on frame generator, you give it time for it to load. Automatic frame generator, and this is what we have. All right, so let's get into it. The first one is B. What this means from the diagrams here, you should understand what B is. This is only one B. If we add, click on add, you notice that this is one B and this is another B, so those are two B's. But for the sake of this tutorial we're going to be dealing with one B, so we can just delete this. Okay, and we can click on mirror. So what, okay, we won't do that here since it's one B, we just won't do that there. So our structure dimensions, what is dimensions for your D? Dimensions for D, let's use 25. Okay, for D, and Structure dimensions n is the number of roof rafters you want for that dimensions. So we want about 5 spacing, 5, so n is going to be 6. So you press enter, and once it's 6, you notice you can come here and count it: 1, 2, 3, 4, 5, 6. Okay, so the dB, the spacing between each rafter, each of these 6 rafters, is 5 meters. We want a spacing of 5, so it's 5 meters. This 25 meters, and n is 6. If you don't want equal spacing of frames, you can come to and click arbitrary spacing of frames and edit how you want your frames to be spaced. But we are using an equal spacing for our frames. So next we are going to do is to come to our geometry. You leave this, come to our geometry. What kind of roofing? So for our geometry, for the B1, we have what kind of geometry do you want? Okay, do you want a single pitch? If you want single pitch, see it's going to change to a single pitch. Do you want a gable roof? Okay, and we want a gable roof. So with that, do you want a base symmetry? That's whatever happens on the left side to happen to the right side. We want a base symmetric portal frame, so we click on base symmetry, and you notice that whatever you have, whatever you change here will also be changed there. So for our HR, you come here to know what some of these annotations mean. So for HR is from the top of your column to the apex of your gable roof, to the apex, from the top of your column to the apex of your gable roof. So you can either impute that, okay, or if you know the angle, you can actually impute that also. Okay, so we are going to be using the height of about 1.5. Press enter, and 1.5 will give you an angle of 11.3 degrees. Okay, HCL, come here. HCL is from the top to the bottom of your column, your steel column. Okay, so we are going to be using HCL of 6.400 millimeters. That's 6 meters, 450 millimeters. Okay, HFL, which is how deep you want your column to enter into the ground. This is a normal ground level. We're going to be using 0.45. Press enter. Okay, so our B, what dimensions do you want for your B? Our B, we want our B to be, I'm going to leave our B to be 15. I'm going to leave our B to be 15 meters. Okay, I'm going to leave our B to be 15 meters. Okay, as support, we want our support to be a fixed support. We want support to be fixed. Our support fixed, not pin. We're fixing our support. Okay, so our columns, what section do you want for your column? So you click, you have a drop down menu. So in case you don't have the sections, because we are using UK sections, in case you don't have the sections here, you can just click on more. It's going to give you a list of sections where you can pick from. Section type is steel. We're using S275. Okay, so what kind of database are we using? A European. We want to use UK sections. We want to use UK beam. We want to use UK sections. Okay, what family do you want to use it? What family you want in? You want a UK beam for a column. You want to use UK beam for a column. Well, let's use a universal column. So we click there. You see universal columns. Okay, so what section do we want to use for our columns? The section we want to use for our column, let's just assume a section. Section we want to use for our column is 203 by 203 by 60. So you click on it and you add. Okay, so you've added that for columns. So as not to come back here and do the same thing again, we can just also use this opportunity to pick sections for our beams. When you come here, you come to family, you pick a U beam, universal beam. See, it has changed, the family has changed, universal beam. We're going to pick a let's use a 305 by 102 by 20 by 33. 305 by 102 by 33. Click OK, and you add, and you close that. Okay, so you can come to your sections for your columns now. Click on it, come to your UC column 203 by 203 by 60. Click OK, and that has been added. So for our beams are your gable roof rafters. That's what it's there for, your beams. So you click on it, and we use the U beam 305 by 102 by 33, and click on it. Okay, and that's, you've picked sections for your columns and you've picked sections for your beams. Okay, so how do you want your roof structure, the truss? How do you want your gable roof to look like? Do you want to use a beam, a U beam member, or you want it to look like a truss? You want it to look like a beam member, so we click this. Okay, roof deck slab. We won't be having any deck slab for this portal frame, so we can exit this, leave this, go to eaves and attics. Do you want eaves? You're not going to be, but then if you click on left eaves, you see it's going to be added here. Click on right eaves, it's going to be added here. So it depends on what you want, but on these tutorials we don't want eaves, so you untick that. You want attics, you can click on it and also see what that does. Okay, but we don't want that. Come to brackets. Personally I don't like adding brackets here. Usually like adding brackets much later in my design process, but then you can also do that if you want brackets for your brackets of column and knee. You can just click it, okay, and you add what you want to add, but I usually add this later on. Okay, so but then we'll be adding this later on these tutorials. Okay, so come to polines. So how many polines do you want? The first thing you click on, if you don't want poline, you can off it, but then we need polines. So how many polines do you need? Okay, we are going to use let's use about 8 polines. Press enter. About 8 for the left side, and we use about 8 for the right side. Okay, so you see there are 8 polines on this side and there are 8 polines to the other side. Or if you don't want to put it by the number of polines, you can use spacing to impute your polines. Your dimensions notation, you have DPRL for the left side. So DPRL, what's the distance from the apex to the first poline? We are going to use 0.2 as it's been provided already by the software, 0.2. Also your DPCL, DPRR and DPCR. Okay, you're going to use a 0.20 meters, 0.2. So types of poline. If you want a single or a continuous poline, we are going to use single. Single poline means that it starts from the first roof rafter to the next roof rafter. Okay, another one starts from here, another one starts from here. It's not, if you click on continuous, that means it runs from the first to the end, from the beginning to the end. We are going to be using single polines, right? So what sections do you want to use for your polines? What sections are you using for your polines? So you can come here and pick a section, or you come to more, as we did earlier. We were picking for, okay, so what sections do you want to pick? You want UK section. What sections do you want to pick for your polines? We want to see sections. We are going to use standard section. Let's use a C channel, C shape. Okay, let's use a parallel flange channel. Okay, and we're going to use a parallel flange channel 100 by 50 by 10. We add. So instead of ending this and coming back, we can come and also pick a member we want for a ridge beam. Okay, we can still use this, or we can decide to off that, but then let's pick a member for that. You can still use this. Okay, for the roof you can still use this member. Okay, for our struts, what member are we using for our struts? click on my section. Sorry, we're going to use universal beam. Okay, we're using U127 by 76 by 13. Okay, and we add that. Okay, we close. So for our polylines, we come check PF. This for our polylines. Root beam, we can pick that again. So for our struts, the left side of our struts, we'll be using UC127 by 76 by 13, and also here UC127 by 76 by 13. Okay, come to brackets. Brackets is more like your, come to breezing. Sorry, not brackets, breezing. So number of breezing on roof slope, number of breezing, we don't want 3, we want 2 breeze 2. Press enter, you see it has changed. This is 1, this is 2, 1 and 2. If we increase this to 4, for instance, press enter, you see it changes. It has 1 2 3 4, but then we want to use 2 for our roof breezing. So 2. How do you want to breeze it? You want a breezing on the first here. We want another breezing to be at the third here. We don't want breezing at the fourth span. Okay, but then we want breezing at the 5th. Okay, it's always important to breeze your portal frame to reduce or minimize sway. Okay, so this is how we want it. We want it breezing like this on the 1st, we want it on the 3rd, we want it on the 5th. Okay, so for your is breezing for the roof. So for your wall breezing, what members you want to use for your wall breezing? Let's say we are going to be using angle irons for the breezings. So we come here, equal angle, so we check it's not here, come to more. Okay, these angles, family EQA, equal angles x and y axis parallel to legs. So for equal angles, we are going to be using 70 by 7 for our breezing. Click add, close. So for our breezing, equal angles 70 by 7, and here we're going to be using 70 by 7. So also for the roof breezing, we are going to be using the same member for roof breezing, equal angle 70 by 7, and that's that. Okay, next option for your structure is going to be an outer wall. How do you want a outer wall to look like? Do you want it plain, or you want it like any of this? So we are going to be using this. Okay, so what column section do you want to use there? We are going to pick something smaller because those ones don't carry too much load, so we are going to pick a smaller section. So we come to more, column, universal columns. We're going to pick 152 by 152 by 23. You add, close. You see 152 by 152 by 23. Okay, what do you want the support? You want the support to be fixed. Don't forget fixed support. So you come to your loads. You can decide to add your dead loads and live load, but I don't want to add dead and live loads to my roof members now. I want to add a cladding on top of it, so I wouldn't be adding that now. But then you can still add that. But for this tutorial, we won't be adding that. We'll add that much later in the design process of the tutorials. So once that is done, you come to OK. Okay, do you want to save changes to the structure? You press yes. So want to save it, you can save. We'll be saving it as a robot file. Okay, so we're saving it as robot and RTD file. Okay, so we are going to do this to be portal frame. Name is going to be portal frame. Okay, and you save it. Give it time while it produces your portal frame. See, it's sending. So once that happens, is you notice you have your portal frame. Notice X, the bracing, equal angle of 70 by 7. You picked the polines, PFC channel, this, the struts, your roof beams, UK beam 3, U beam 305 by 1 by 33. All of that. So that's how you model a portal frame using the frame generator from Autodesk Robot structural analysis. Please don't forget to subscribe to this channel and like the video.